Alright everybody, welcome back. In this video and the next video, we're going to look at how we find the second derivative using implicit differentiation. So basically, the whole process is we're going to take the derivative using implicit differentiation, find the first derivative that way. Then we're going to take whatever we get as our first derivative, and we're going to find the second derivative. Now when we do this, a lot of the time the second derivative contains a dy dx, and we're going to have to substitute dy dx in and then simplify. So let's take a look at what this looks like in this first example. We're going to find dy dx and d squared y dx squared if x to the third plus y to the third equals 27. All right, so the first thing I'm going to do is use implicit differentiation to find the first derivative. The derivative of x to the third is 3x squared. The derivative of y to the third is 3y squared dy dx, and the derivative of 27 is 0. Now I'm going to solve this for dy dx by subtracting 3x squared from both sides and dividing both sides by 3y squared. And now it is highly advisable at this point in time to go ahead and simplify and reduce this fraction before we start taking the second derivative. If we do not, we put ourselves in great risk of having just way too many constants bouncing around that are completely unnecessary. Alright, so we've got dy dx equals negative x squared over y squared. And it doesn't matter where we put the negative sign here in our derivative. We can put it in the numerator, we can put it in the denominator, we can put it out in front of the fraction. Whichever we choose is just going to dictate what happens as we take that second derivative. I'm going to opt to leave the negative sign out in front of the fraction, because then it's just a constant multiple of the derivative of the fraction. So now we're going to take our second derivative. The derivative of dy dx with respect to x is d squared y dx squared. That's going to be equal to the opposite of, and now in order to find the derivative of x squared over y squared, I'm going to apply the quotient rule. So we've got low times the derivative of high minus high times the derivative of low. Oops, got a little bit ahead of myself there. And the derivative of y squared is going to be 2y dy dx. All of that over the denominator squared. And now in my simplification, I need to substitute, since I have this dy dx here, I'm going to replace it with what dy dx is equal to. And so I've got d squared y dx squared equals the opposite of this whole thing, 2xy squared minus 2x squared y times the opposite of x squared over y squared, all over y to the fourth. And now I want to simplify this piece of my numerator, and I'm going to go ahead and do that. We've got d squared y dx squared equals the opposite of 2xy squared plus 2x to the fourth over y. All that's over y to the fourth. Now I do not want a fraction inside of a fraction here. So to clear the y out of the denominator up in the numerator, I'm going to take both the numerator and denominator and multiply them by y. I've got d squared y dx squared equals the opposite of 2xy to the third, don't forget to multiply that term by y, plus 2x to the fourth, all over y to the fifth. This is one of my favorite simplifications now. We're going to factor a 2x in the numerator And then we're going to replace this y cubed plus x cubed right here with a 27. Now how do I know that y cubed plus x cubed is equal to 27? And that goes back to the original equation. X cubed plus y cubed equals 27. And I can make that substitution back in, and we end up with our second derivative being negative 54x over y to the fifth. So there's my second derivative, and there's my first derivative, using implicit differentiation. Okay, let's go on to example 2. We're going to find the first derivative and second derivative given this scenario here. So I'm going to go ahead and take the derivative implicitly. I've got the derivative of 1 is 0, and then the derivative of 2x squared y squared. I'm going to use the product rule. I have a constant multiple 2. I've got x squared times the derivative of y squared plus y squared times the derivative of x squared. And that's equal to the derivative of 9, which is 0. And so I've got 4x squared y dy dx plus 4xy squared equals 0. Solving for dy dx, we get dy dx is equal to negative 4xy squared over 4x squared y. And of course, I want to reduce this before I start taking the second derivative, because it's going to make my life considerably easier. I'll bring the negative sign out in front. We've got everything except for a y canceling from the numerator and an x from the denominator. 4's cancel, an x cancels from both, and a y cancels from both. And there's my first derivative. And now I'm going to proceed from there to go ahead and find the second derivative. So d squared y dx squared is equal to the opposite of low times the derivative of high minus high times the derivative of low all over low squared. And now I need to substitute dy dx in there, which is opposite of y over x. And this turns into negative y minus y over x squared. Simplifying the whole fraction, we end up with our second derivative being equal to 2y over x squared. We've got a negative 2y in the numerator, and I just bring that negative sign from in front of the fraction. And there's my second derivative. Alright, that's going to be it for this video. We'll come back in the next video and look at example 3 from this lesson. See you guys then, and hope you have a great rest of your day.